Newton's first law states that an object at rest stays at rest and an object in motion stays in motion unless it experiences a net external force. The following is an example of an object in motion staying in motion. The object was a crate full of chains in the back of a truck traveling about 4 meters per second. The truck came to an abrupt stop, but because the crate was not tied down, and therefore it experienced no net external force, it continued to move forward at 4 meters per second until it hit the toolbox of the truck. The bedliner of the truck was removed to decrease friction. The next video will demonstrate the second part of Newton's first law, an object at rest staying at rest. The object in this video was the same crate on the tailgate of the same pickup truck. The truck and the crate were both at rest. When the truck accelerated forward, the crate resisted this, stayed stationary, and fell to the ground because the truck moved from beneath it. Newton's second law states that the acceleration of an object is directly proportional to the net external force acting on the object and inversely proportional to the mass of the object. The following video shows a pool ball being hit with a small force hitting cue chalk. When the pool ball struck the chalk accelerated forward with the same amount of force that the pool ball had. The following video shows the same pool ball being shot at the same piece of chalk with a much greater force. As in the last video, the chalk accelerated forward with the same force the pool ball had. This time, though, the acceleration was much greater because the force was, and they are proportional. The next videos will demonstrate two objects of different masses having different accelerations. Here, a ping pong ball was shot with a cork gun and experienced a lot of acceleration because it had little mass. The next video shows a pool ball being shot by the same cork gun. The pool ball only accelerated a small amount compared to the ping pong ball because it has a much greater mass. Remember, acceleration and mass are inversely proportional. Newton's third law states that for every action there is an equal and opposite reaction. If two bodies interact, the magnitude of the force exerted on object 1 by object 2 is equal to the magnitude of the force simultaneously exerted on object 2 by object 1, and these two forces are opposite in direction. The following video shows a pool ball being shot at another pool ball of equal mass. The video shows that after the two balls struck each other, the first one accelerated backwards until it did not move in the forward or backward direction. It also accelerated to the left because it struck the second ball at an angle. The second ball then accelerated forward and to the right with the same force as the first ball. The first ball stopped moving forward because the second ball exerted a force on it of the same size but backwards. It also accelerated left because it struck the second ball with a rightward force. The second ball accelerated forward with the same force as the first ball and to the right with the same force as the first ball. The next video shows two objects of differing mass exerting a force on one another. In the video, a pool ball was shot at a ping pong ball. The ping pong ball pushed back on the pool ball with the same force that the pool ball had hit it with. This caused the pool ball to slow down a little bit. However, the ping pong ball experienced a much greater acceleration than the pool ball because its mass was far less. This ties into Newton's second law as well.